I welcome you all about what is long-term dependencies, leaky unit, and skip connections and dropouts in RNN, recurrent neural networks. We'll see one by one. Long-term dependencies means the long-term dependency. The definition for long-term dependency is this long-term dependencies. What it means, long-term dependency refers to a situation in sequential data where information that appears at an early time step must influence the prediction at a much later time step. In many real world problems, if you are taking the real world problems such as language modeling, speech recognition, or biomedical signal analysis, important context may occur for earlier in the sequence. For example, in a sentence, the subject of a sentence may appear at the beginning, but the verb agreement must happen much later. The patient admitted last week is recovering. Here, the verb is depends on patient, not week. Okay. So we can say that the subject of a sentence may appear at the beginning, but the verb agreement must happen much later. If the model fails to remember that early information, the prediction becomes incorrect. Thus, the ability to capture long term dependencies is essential for accurate sequential modeling. Next, RNN, the memory flow, how it would be. In a recurrent neural network, the memory is stored in the hidden state, which is updated at each time step using both the current input and the previous current input and the this is the previous hidden state. This is the formula has been given by ht is equal to f a function of this may be the activation function wh of t minus 1 plus wx into xt. It shows that the previous hidden state acts as a memory carrier, transforming information forward through time. This time step-by-step passing of information allows the network to theoretically remember past inputs. However, because memory must travel through many transformations, important information may weaken or distort as time progresses. Next, the vanishing and exploiting gradient in RNN. During the training, the RNN use backpropagation through time, where gradients are propagated backward across many time steps. This involves repeated multiplication. Here, see here, this symbol represents it. It is not a pi, it is a repeated multiplication of weight matrices and derivatives. If these values are smaller than 1, gradients shrink exponentially, causing the vanishing gradient problem where early layers receive almost no learning signals. If the values are larger than 1, gradients grow uncontrollably, causing exploiting gradients and unstable training. Both issues prevent the model from learning long-term relationship effectively. What are next here? This is the equation dou L by dou HT is equal to dou L dou HT. This is the repeated multiplication WH f dash of AK. Here the weight is less than 1 means gradients or will be vanishing. Weight is greater than 1 means gradients will be exploiting. That this means long term information is lost. Next, what are leaky units? Leaky units modify the hidden state updates to include a controlled memory retention factor. Instead of completely replacing old memory with the new information, leaky units allow part of the previous state to remain. The equation ht is given by alpha into ht minus 1 plus 1 minus alpha into function of wxt, where the alpha value is in between 0 and 1. It introduces the parameter this alpha that determines how much fast information is retained. This mechanism ensures that memory does not disappear abruptly and provides a smoother transition between old and new information. What is the role of leaky units? The leaky units help maintain long term memory by ensuring that the information decays gradually instead of vanishing points. Vanishing suddenly. This gradual fading supports stable gradient flow and improves learning in long term sequences. Such units are especially useful in continuous signals like ECG or EEG data, where patterns unfold slowly over time. By retaining part of the previous state, the model can capture temporal dynamics more effectively. It will be useful in time series and biomedical signals like ECG and EEG. What are skip connections? Skip connections, also called residual connections. It introduces direct pathways that allows information to bypass intermediate transformations. Instead of relying only on sequential updates, the model adds the previous hidden state directly to the current transformation. This design creates shorter paths for gradients to travel during training, reducing the risk of vanishing gradients and improving convergence in deep networks. This means it has been given by ht is equal to f of ht minus 1 comma xt plus h of t minus 1. And what are all the benefits of skip connections? The primary benefit of skip connection is improved gradient flow. And since gradients can travel through shorter routes, learning becomes more stable and efficient. These connections also allow deeper RNN architectures to be trained effectively, as earlier features are preserved and reused rather than overwritten. As a result, the network can model complex temporal relationship without losing any important early information. Next, what do you mean by dropout in RNN? This and all we have seen it in the previous lectures. Dropout is a regularization technique where certain neurons are randomly deactivated. Dropout means some neurons will be deactivated during training. By multiplying the hidden state with a binary mass, some activations are set to 0. This forces the network to avoid relying too heavily on specific neurons and encourages the learning of distributed, robust representations. Why dropout is important? Yes, it is very, very important. Without dropout, neural networks can overfit the training data, memorizing noise instead of learning general patterns. And a dropout combats this by making the network behave like an ensemble of many smaller networks. This improves the generalization performance and reduces co-adaptation between neurons, leading to more reliable predictions on unseen data. That means variational dropouts. Next, this is the difference between the combined approach. What do you mean by here the so you know that the types of RNN and all. This is the combined approach. The leaky unit. If you are taking modern sequence models, often combine multiple technique overcome RNN limitations. Leaky units helps to retain long-term memory. Skip connections ensure smooth gradient flow, and a dropout provides the regularization. That means it avoids the overfitting. Together, these methods create a balanced system that learns effectively from long sequences while avoiding instability and overfitting. This is the main advantage. Coming into the summary, so, this ordinary RNN, recurrent neural networks, struggle with the long sequences due to vanishing gradient and rapid memory loss. And advanced mechanism like leaky integration, residual connections, and dropout addresses these issues from different angles. These improvements allow deep sequence model to learn stable representations, retain long-term information, and generalize well to new data, making them suitable for complex real-world applications. Hope these enable the stable training data for long-term sequential problems. Hope everyone understood about the basic concepts about this long-term dependencies, leaky units, and skip connections. The remaining things we'll discuss in the next lecture. Thank you.